Hey everyone, welcome to Rotation Notes 2.02. Looking here, we have a capital R this time for rotations, 0, 90. This 0 actually says the origin. So we're rotating around the origin here. So rotation of 90 degrees around the origin is always going to go counterclockwise. So this is a little bit backwards. When you go positive 90 degrees, you're going to turn your paper to your left, okay? So you're going to turn your paper counterclockwise. So sketching and starting exercise 1 here. So again, rotations are our turns. We're going to turn the paper. So example 1 says sketch the point A, -2, 1, and rotate it 90 degrees. So again, 90 degrees is going to turn our paper counterclockwise. So our point A is to the left 2, up 1. I'm going to graph it here. Okay. Now, right now, this is my x-axis, this is my y-axis. All I'm going to do to my paper is I'm going to take my paper and I'm actually going to turn it. All right, so this is what I'd like you doing for these questions. So for point A, we go to the left 2 and up 1, and we're going to rotate our paper to the left. Okay. Now, we're going to pretend that this is our x-axis, this is our y-axis. So this ordered pair is to the left 1, down 2. So the ordered pair for A prime is to the left 1, down 2. So we read the new ordered pair. Okay. I could tell you the rule to take the x and the y and switch them and negate it, but this option of actually graphing and rotating your paper is preferred method. Now, when I go back to regular version of our notes, what I'm going to do is now I'm going to graph that new rotated point. A prime is to the left 1, down 2. So this is our new location, A prime, to the left 1, down 2. And if I go and I connect A to the origin, and then the origin to A prime, you can see that we have this right angle. And therefore, that point A rotated to the left 1 quadrant. Okay, we're going to do the same thing with point B. So looking at the second picture, we have point B, and it says to sketch and rotate point B and rotate it -90. So this kind of gotten a little bit backwards on your line. But a rotation of -90 tells us to move to your right 1 turn. So again, we're turning our paper 1/4 turn in a direction. Okay, so 90 degrees means 1/4 turn, so that the top of our paper is now situated to the right side of our desk. Okay, so let's graph the point B for -1. Now notice when I do my little dash marks, I'm not putting them in every direction. I'm just going 4 to the right and down 1. I'm graphing just point B. Okay. Now again, like we did with the first picture, we're going to now take our paper and rotate it -90. So that's going to turn us, CW here means clockwise. So now we read new point B. So B prime is now to the left 1, down 4. So now we read the new ordered pair as if this is our x-axis and this is our y-axis. So we're going to practice some of these rotations, and if you need to pause the video, go back, start again. Again, we graph our original point as if x was going left to right, y was going up and down. Then we rotate the paper. Okay. Now, if I were to graph our new ordered pair, B prime is to the left 1, down 4. And again, I'm going to connect my point B to the origin. So again, I'm connecting back to the origin because that's considered my center of rotation. And then from the origin to B prime, you notice, again, we went 90 degrees. So there's a 90-degree angle there from B to B prime. So this point B rotated 1/4 turn to the next quadrant, okay, which would be quadrant 3. So it moved from quadrant 4 around over to quadrant 3. Looking at the next case. Here, we're going to rotate 180 degrees, which is 2 quarter turns. So that's 90 degrees 2 times. A rotation of 180 is the same as our reflecting in the origin. So when we look back to our cheat sheet next class, we're going to say that rotating a picture 180 degrees and reflecting through the origin is the same thing. And if you remember the rule here, it was x comma y becomes negative x, negative y. We change the signs of both images. And we're going to graph it here and rotate. So our point is -3, -1 is point C here. Okay. So sketch the point C, -3, -1, and rotate it 180. So what we're going to do with our paper is we're going to take our paper and rotate it upside down. Okay. So now everything's upside down. But now we're going to treat this as the x-axis, this is the y-axis. Anything to the right is positive, anything up is positive. So that point C is 3 to the right and 1 up. So our ordered pair for C prime, the image, is now 3, comma 1. So it started as -3, -1, and now it's changing to +3, +1. So again, we're going to graph and actually rotate that paper around to practice these rotations. So if I were to graph C prime, our new ordered pair that we wrote kind of upside down here, is 3, comma 1. So again, if I were to connect that to the origin and back through, we do make an angle of 180. Now I'm going to say it doesn't matter if we turn it right or left this time, because turning your paper upside down, it doesn't matter if you turn it to the left twice or to the right twice, it's going to be the same. So for 180, -180 or +180 are equal. Okay. Moving back over to here to the rotation 90, rotation -90, I do want to talk about 270 degrees, because that's going to come up on number 3 here. Rotation of 90 is the same as a rotation of -270 degrees. So 270 degrees is 90 times 3. So it's 3 turns. So if I go once to the left, remember that's the same as going 1, 2, 3 times to the right. So again, negative turns go to your right, positive turns go to the left. So that's myself trying to draw you an arrow around in a circle there. All right, but 1 quarter turn to the left is the same as going 3 turns to the right. So looking at the next exercise, for numbers 1, 2, and 3, I give you the same ordered pairs, A, B, C, D, A, B, C, D, and A, B, C, D. They're all the same. I'd like you to graph that shape. So if you could pause your video and graph that shape. We have A being 3, 5, B is 6, -4, C is -1, -8, and D is -4, 1. With that, notice I did use a straight edge as I connected those points. And if you were in class the other day, I gave you a post-it or index card to graph that. Okay. So we're going to find the image of that quadrilateral, that 4-sided figure, after rotation of +90 here. So rotation of +90 tells me to turn to the left 1 turn. So I'm actually going to take my paper. If A is starting in my first quadrant, I'm turning it to my left first. So I'm going to rotate my paper so that now it situates with my name line over to my left. Okay. And now we're going to read these new points. Okay. So now this is my x-axis, this is my y-axis. So point A from my origin is 1, 2, 3, 4, 5 to the left and 3 up. So +3, +5 becomes -5, 3. Okay. Point B. So I'm keeping my paper rotated as I read these new ordered pairs. So that's now in the first quadrant. So we go 1, 2, 3, 4 to the right, 1, 2, 3, 4, 5, 6 up. So notice the digits don't change. I had a 3 and a 5. I still have a 3 and a 5. Here, now I have a 4 first and a 6 second. So they do switch their order and something changes its sign, but those rules are kind of complicated. So I really want us getting in the habit of graphing our shape, rotating the page, and then reading these new ordered pairs. So if this is our origin, C is 8 to the right and 1 down. So that's going to become 8, -1. And the last point, D, is now 1 to the left and 4 down from the origin. So again, I'm treating this as my y-axis, this is my x-axis. So -1, -4 is my new ordered pair. So I could graph the new one. I'm going to skip that because I don't want to confuse us with the graph paper right now. But those should be our new ordered pairs after a rotation of +90. Okay? Now we're going to practice a rotation of 180. So again, we turned our paper to the left this time. I did forget to write that in. So exercise 2 says, find the image of each point after rotation of 180. So again, I graphed this quadrilateral here, ABCD, and we're going to find the image after a rotation of 180 degrees. Now 180 degrees, remember, is the same as reflecting in the origin. And we learned that last time. X, y would become -x, -y. So if you like the rule, you can just apply that. So using that rule, A, 3, 5 becomes -3, -5, and let's test that out. So I'm going to take my paper, okay, I'm going to rotate it upside down, all the way upside down. So A is now at the bottom of my page where it was at the top. So now reading point A from this origin, we go to the left 3, down 5. So if it started as +3, +5, it becomes -3, -5. Make my negative a little bit more prominent there. Okay. So again, point A became -3, -5. And if you have to rotate your paper upside down to keep writing, you can. B goes 1, 2, 3, 4, 5, 6 boxes to the left, 2, 3, 4 boxes up. So it's -6 up 4. So B prime becomes -6, +4. C prime is now 1 to the right and 8 up. So it becomes +1, +8. Now look at those ordered pairs. It was double negative, -1, -8. Now it's double positive, +1, +8. And point D is 4 to the right, but down 1. So upside down, it becomes 4 to the right and down 1. Okay. So again, the process here is to graph your original shape, actually turn your paper in the direction that you need to. For exercise 3, find the image of each point after rotation of 270. So this is a positive rotation, so we're supposed to turn to the left 3 times. Well, this is the same as a rotation of -90 would mean turn to the right 1 time. Okay, so I'm going to just remind you that turning to the left 3 times, okay, taking 3 left turns around the block. If we think about a block here, if we're starting here, and I take a left turn, a left turn, and a left turn, I end down in the bottom right corner, okay? That's the same as if I started here and I take 1 right turn, I end in the same position. So 3 left turns is the same as 1 right turn, okay? So what you can do to your paper is if you want to turn it once to the left, A jumps to the left 1 time, A is going to jump 1 more time, a second turn, and a third turn. Is going to put A down here in the second quadrant. So again, it started up here when we had our page right side up. Now it's moved 1 turn to the right. Okay. Now we're going to read the ordered pairs from here. So A triple prime becomes 1, 2, 3, 4, 5, 6. I'm sorry, 5. 1, 2, 3, 4, 5 to the right, down 3. So 3, 5 becomes 5, -3. Okay. Point B is now 6 4 to the left, 1, 2, 3, 4, and down 1, 2, 3, 4, 5, 6. So it's 4 down, 4 to the left, 6 down. So that becomes -4, -6. C becomes -8, +1. And D is 1, 4. Now, I hope I'm not the only one just twisting my paper around kind of crazy here. I really need you to engage in these notes. Actually rotate your papers. So for the next example, I'd like you to take a look at what's graphed for us. Okay. I'm going to ask you to pause the video after you write down your ordered pairs here. So V, J, R, and Y. V is 2 to the right, up 0. J is 1, -1. R is 1, 2, 3, 4, -3. And Y is 1, 2, 3, 4, 5, -3. So after writing down these ordered pairs, what I'd like you to do right now is pause the video, okay, and actually do this rotation. So rotate it 180, okay, list down your ordered pairs, and graph. Okay, so it says here, state the coordinates of quadrilateral VJRY. We've done that. We read the ordered pairs from the original picture. Now graph and state the coordinates of V prime, R prime, J prime, Y prime after rotating at 180. So what we're going to do here is we're going to find the new ordered pairs. Now you could use the rule, XY becomes -X, -Y. Okay, or you can take your paper, rotate it upside down, and write in the new ordered pairs, okay? Then I'd like you to graph it from there. So I'm going to pause, ask you to do it on your own. And this is what we should be getting, all right? So that shape jumped 2 quadrants around. If I were to take a little piece of paper here, kind of trace over my shape, just to show you, if I took that little Post-it note and I rotate it up to the first quadrant and around to the second quadrant, it should fall nicely on top of what I have. Okay, so this is your rotation. It starts in the bottom right quadrant, and around my center of rotation, it goes 1 quadrant up, 2 quadrants around. Okay, so V prime jumped over to here, J prime, R prime, and Y prime. So that's a rotation of 180 degrees. Looking at exercise 5. Again, I'd like you to pause your video, graph the triangle. So I already have it graphed here for myself, 1, 4, 3, 0, 4, 5. So 1, 4, 3, 0, 4, 5. I'd like you to pause the video and actually perform this rotation. So graph and state the coordinates of D prime, E prime, F prime, the image of the vertices triangle DEF under a rotation of -90. Now -90, remember, turns to your right 1 turn. So if I turn it to the right, I'd like you to read those new ordered pairs. Now this is where you have to forget about the positives and negatives on the X and Y axis. To the right is positive, but this becomes a -1. So D becomes 4, -1. So I'd like you to write down your new ordered pairs and graph your rotation. So looking at the rotation here, if we graph that first triangle, again, DEF is here in the first quadrant. What I'm going to show you with this little piece of paper, so this is called tracing paper. It's like wax paper. It's kind of see-through. If I hold that up to the origin and I kind of traced over my triangle DEF, again, we're turning to the right 1 turn. So I'm going to do is I'm going to hold this down in the middle of my quadrant. I'm actually going to rotate that triangle around the origin. Okay. That finds us our new 3 ordered pairs. So when you actually physically rotate your paper, or if you have this tracing paper, I can get you a little slip of it when you come to class next. We can take that image and actually rotate it through the origin to find its new positions. So D prime is over 4 down 1, so 4 negative 1. E prime is 0 negative 3, and F prime was over 5 down 4. And if I graphed that quickly, 4 negative 1, 0 negative 3, 5 negative 4. Again, I should be using a straight edge here. That triangle rotated 1/4 turn over. Okay. This last case, we have to read carefully here. The coordinates of the vertices triangle RST are negative 2, 3, 4, 4, and 2, negative 2. I've graphed that here for us. Again, negative 2, 3, 4, 4, 2, negative 2. And triangle R prime S prime T prime is the image of triangle RST under rotation of 90 about the origin. So in this case, they tell you 90 degrees and we're turning around the origin. So that's our center of rotation. So when we hold our papers still, we're rotating around that center. We're going to have a different notes page later about a different center of rotation. But state the coordinates of R prime, S prime, T prime. So again, positive 90 turns you to the left 1 time. So that's backwards. You have to remember that rule. That positive 90 turns you to the left. So if I take my paper, and it's easier here to just rotate to the left 1 time, we're going to find R prime, S prime, and T prime. So reading those new ordered pairs from our picture, R is now 3 to the left and 2 down. So it becomes negative 3, negative 2. S is now 4 to the left and 4 up. So that's negative 4, positive 4. And T is 2 to the right and 2 up becomes positive 2, positive 2. And in this case, if I reread the question, it doesn't ask us to graph its rotation. It just says to state the coordinates of the new R prime, S prime, T prime. So this is all that was required for this question. Okay. Moving, and again, I'm sorry I went through that a little fast. I'm trying to keep this video short and sweet because I know you're going to do some pausing during it as you're taking your notes today. So again, graph your paper, rotate it in the direction that you need to based on our rules. Classwork 202 is a little mixed rigid motion review. So for question number 1, this is a reflection over y equals negative x. Remember your rule there is to switch the order of your ordered pair and negate, if that helps. We wrote the rules on the front page. When you reflect here over y equals x, is the rule to switch. You need to be memorizing those rules. Okay. Exercise 3, I'm going to answer with you. An isometry or rigid transformation, and this is at the very beginning of our notes. We wrote it on the front page. Rigid motions preserve length of sides and angle measures. Preserves lengths of your sides and the angle measures. So again, as I'm translating this trapezoid here, that angle at A is the same measure as this angle at A. Same with our rotation. So just looking at this last picture here, A, B, C, D, okay, this shape rotated around in some fashion. Those angles stay the same. The measure of angle A and A prime here are equal. Okay. Is a reflection an isometry? So isometry is another fancy way for rigid motion. Those 2 words mean the same thing. And yes, it will be. So reflections are an isometry, and the reason is because sides and angles don't change their size. Here, be careful going from the original to the primes. We looked at that in our warm-up last class. Number 5 is multiplication. Multiple choice, my mistake. And this asks, is a rigid is a rotation of rigid motion, and explain. So the same answer for 3 you're going to use here for number 6. Same type of question if you want to reread that to understand it. Exercise 7, the 0.35. For this one, I would suggest to just sketch a little picture like we did at the beginning of our notes today. +3, +5 is this point A, and it asks you to rotate in the one direction. So give me the new ordered pair for A prime. And for number 8, it asks you to graph the shape ABC, graph and state the coordinates of the primes after a translation. And then for here, we want you to take this image, and that's what we get rotated 180 degrees. So for this picture, the original triangle you graph, we want you to translate it, use your translated triangle to then rotate. Okay? And then they have a question here at the bottom we'd like you to try. Good luck with your notes and your classwork. Again, please make sure to upload a picture of something by the end of this block to make sure we are all on the same page moving forward. Thank you. Good luck.